So let's say we're given a function, was the equation y is equal to f of x. It's going to be the blue curve, and I will choose some point A and slightly different point from the a plus delta x. So if I find the values of the functions, they are going to be these two red points. So the difference between the points on the x direction is going to be denoted as a delta x. It is how the points are changing in the x direction. And if I would like to measure the change of the height of the function, I need to take the difference of the heights, right? And the difference of the heights is denoted as a delta y. And this dy measures the change of the height on the tangent line, right? So if I would make the tangent line at this point, then if I would find a point on the tangent line for this point, a plus delta x, the change of the height between this point and this point is going to be dy. And this is denoted as the differential, actually, right? So we call this dy as a differential, and actually we can evaluate this by multiplying the derivative of the function at this point, multiply it to the dx. Basically, it means that differential is found by multiplying the rate of change of the function in the direction of the x, multiply the change in the direction of the x. And please note that we can, if we divide the dx from the both sides, dy divided to the dx, it's going to be f prime of x, right? So actually here dy measures the difference of the height of the tangent line, right? And dy dx, it's the slope of the tangent line, right? So the change in the y of the tangent line, right? So the change in the y between the 2 points on the tangent line and change on the x, it is going to give me the slope, right? So this is exactly matches with the definition geometrically and algebraically. So now let's talk about the total differential for the two-dimensional functions, multivariable functions. Analogously, what we did before here, I would like to obtain the total differential. So the differential for the y was equal to the rate of change of the function in the x direction multiplied to the change in the x direction, right? So that is why if I would write down the differential for the z, I would need to write the rate of change of the function f in the x direction multiplied to the change in the x direction, right? It is going to be the rate of change of the f in the x direction is the partial derivative of the f with respect to the x multiplied to the change in the x direction, which is dy, plus the rate of change of the f in the y direction, because the function now depends on the two variables, multiplied to the change in the y direction. So this is called the total differential, and its actual meaning is, so the change of the height of the tangent plane, right? Well, previously dy measures the difference of the height of the tangent line, and we can see this from this figure, right? So dy is the difference of the height between this point and this point. So now the dz is going to measure the difference of the height of the tangent plane, right? So let's do an example of calculating the total differential for the multivariable functions. So let's say z is given as x squared plus 3xy minus y squared. What we need to do is we need to find the total differential. So in order to do this, we need to first of all find the partial derivative of the z with respect to the x. So I need to take the derivative from this function, where I look to this and see that the y is a constant. So it's going to be tx, right? So please note that y and 3 are the constants. So I can take out the constants and multiply this to the derivative of the function, which is x1, minus the derivative of a constant in a square is 0. And what I will have is tx plus 3y. So where I take the derivative of the z with respect to the y, it's going to be constant. So the first one is a constant 0 plus 3x minus ty. Right? It's going to be 3x minus ty. So if I put them out as a formula of the total differential, so the change of the height of the tangent plane, right? It's going to be equal to the partial derivative of the z with respect to the x is tx plus 3y multiplied to the dx plus 3x minus ty multiplied to the dy. So actually, we're going to use the total differentials in order to obtain the chain rule, right? So previously here, for example, what I wanted to understand, what is the derivative of the y with respect to the x, right? So what is the slope of the tangent line? It was equal to the f prime of x. And I would like to apply this total differential in order to obtain the derivative of the z with respect to some parameter t.